So my research aims to understand plant extinction in the fossil record, and then by applying this research to modern plants, try and understand how plants will react to the current biodiversity crisis. So fossils are molds of plants from long, long ago that are preserved as impressions in rock, and the fossil record is like a scratchy old vinyl record. The needle jumps and skips, and you hear pieces of sweet music, but you never get the full song. However, unfortunately, 40% of modern plants are threatened with extinction, and the background extinction rate of plants is over 500 times higher than the historical background extinction rate. And this is so worrying because plants underpin every ecosystem on Earth. And what's even more worrying is that we simply don't care as humans about this. We don't have enough knowledge about plants to appreciate them fully, and this means we're not concerned with their conservation. And this is a phenomenon known as plant blindness. So for example, if I was to take any of you guys out into campus today and you saw a fox or a rabbit, everyone would be able to identify it. However, if I pointed to a random plant, most people wouldn't be able to identify it. So what I do in the lab is I look at leaf traits. So leaf traits are things like length, width, and area of a leaf. And what I do is I look at how these relate to climate change. So for example, if there's higher temperatures, then the width of leaves will become narrower because this helps the plant to lose heat without losing excess amount of water. And climate change is predicted to be one of the main drivers of plant extinction going forward in the next few years. And so then, if we can understand which leaf traits correlate to plant extinction or survival in the fossil record, then we can use this information to infer with modern plants which species with which leaf traits may be most at risk of extinction. So although plants certainly react to major environmental upheavals in the fossil record, they don't appear to suffer mass extinctions on the same scale as animals. So on the graph behind me, you can see 5 peaks, and these correspond to the 5 major mass extinctions in the animal kingdom. However, plants, as I said, don't appear to go extinct on the same scale. However, we do see shifts in leaf traits across these mass extinction events. And so by understanding why these traits shift across these boundaries, we can use this information to understand the response of plants to these past events, and then infer that to understand how plants how we can minimize the effects of these events in the future. Thank you very much for listening.